Hello and welcome to week 8 of CIT 225. We're over halfway there, so great job. Everyone's keeping up. Everyone's doing good. So let's talk a little bit. I'm sorry, I don't have a lot of, or actually any code prepared for you tonight for the lesson. This Sunday, I was kind of surprised and called into my bishopric. And so I've been kind of working through that this week. As like I said, a bit of a surprise, but I'm thankful for the calling and the opportunity to serve. But it did mean my week went a little askew. So I wasn't able to get some code. So we'll pick that back up next week. I think we'll be able to keep these on Wednesday night. I might have to push them back to 9:30, which is great for you guys on the West Coast because it's more not in the middle of dinner time for you. So I'll let you know in the announcements next week what exactly is going on with that. As for this week's lesson, week 8, it's very much what we've been doing. If you look back at the previous videos, I've shown subqueries, I've shown how they work. In this case, we're just using different operators. I've already used the in operator. Then you've got any, all, and exists. The difference between in and any, all, and exists is that any, all, exists are just comparison operators, and they'll only return values if the queries meet or don't meet the thing. So like this will show like select column 1 from table where column 2 in, select column 1 from table 3. So we'll do that, but the any, all, and just there, what else am I looking for? They're equivalency operators. But I don't want to delve too deep into those. A lot of the questions, the reading, if you just follow the reading, you'll get them. If you have any specific questions on them, please let me know. I will one-on-one talk about them, but I do want to talk about tonight very quickly in the time that I have about the final project. I've been getting a lot of questions on the final project. So I know we've talked over this before. We're talking a little bit more about, covers some of the same things, maybe a few different things, a little deeper dive. But I want to talk about the different aspects of this, what I expect, and then we'll go over the rubric real quick. So the first thing is to create an entity relationship diagram. So we've talked about those before. That's creating a diagram with at least 12 tables, the relationships between the tables, indexes, foreign key constraints. Any of that needs to be in the ERD. I need to know not only what the tables you have, but how those tables talk to each other. And they have to follow a logical path of information. So, and I've walked through a number of people. And again, if you guys need some one-on-one help, please contact me. I'm available for you. I can help you through this. But if you're struggling on how to make an ERD, pick one table. Pick one table that you know you're going to need and design that table and then go from there. For example, I'm going to do, I think the example I used before is a bookstore. If you go back 2 or 3 videos, I'll walk through it. Let's do something different. Let's say I'm going to do a, I don't know, this movie rentals, bookstores. Stores are usually easier to do. Let's say let's just go through the bookstore example again, because you can look back and rehash, but I kind of want to do it. So the thing we know, if we're opening a store, we need customers. Okay, we need customers. So we can go ahead and create the customer table. And we know that the customer will have last name, first name, they'll have address, they'll have phone number, they'll have email address, they'll have date of birth, they'll have gender, they'll have that's a good example there. So that'll be good. So then from customers, what do we need? We're gonna have employees. So let's write down what we need for our employees, and we'll have that there. And then so it comes to employees, we're gonna need inventory, right? So we're gonna have books. So we'll do the book table. So we'll have book ID, we'll have book title, we'll have publisher, we'll have author, we'll have number of pages, we'll have genre. So let's talk about, we do the book table. So that's what we go for books, right? So we look at this, we have an author column in there. Well, that's a problem. One author writes many books, and one book can be written by more than one author. So now we got to go into the different tables. We can't have an author column in the book table because it's a many-to-many relationship. So we've got to create an authors table. The authors, so we've been through that before. So the point of this conversation here is not to rehash that, but it's just to pick a starting point, and pick a starting point, and then grab that one table and see where that table takes you. And next thing you know, you have one table and now you got 43 and you're not sure how you got to 43 and you only wanted 12. Okay. So that's the easiest way to pick one table and then go through it, get everything on the table and say, okay, what else do I need? And usually when those broad reaching, I need customers, I got to finish the customer's needs. You know, when you go to customers, they got the orders. What did they buy? How did they buy it? How much did they spend? Blah, 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 blah. Okay. That's the first thing. It's a minimum of 12, but you don't have to stop at 12. I do recommend stopping at 12, maybe going to 14, because you have to write the code to build all these, and writing code to build tables is time consuming. You don't want to spend a lot of time on it. Next, create test cases for all, create, read, update, and delete operations against the 12 tables. Okay, so index test case include index the maps user interface, CRUD test cases, mockups user interface, and test cases for SQL script files. Okay, so here's what all this means. Let's forget about the create statement first, because that means the one thing you have to do without question, you've got to create the state. You've got to give me the create statements to create the tables and the indexes and the core keys. I need those right off the bat, because what I do is I open up my desktop and I open up MySQL and I run that code to see if they get built, plain and simple. So make sure you test it to make sure they build, because that's the first thing I'm going to do. So that's easy. The create ones are there. Okay, next, the read. You've got all these tables. How are you going to select them? What information do you have in them that you want to show people? You know, I mean, going to the book database, you know, we want the customers to have the ability to see the previous purchases. So there'll be a history, a purchase history table, a purchase history page. So you got to write a query that shows people everything that they've bought. You want to show, like, you know, when things were, like, what genre of book was bought in October. Is horror the #1 book that sold during Halloween time? So you need to say, okay, if I am creating this application, it's more than just a database here. This is here. I'm creating an actual application. How do I create this application? What is the information that needs to come out of that, and what are people going to want to see? I'm doing a bookstore. I want to see, how many books were bought during September, when we're like, what was the best-selling book in September? Was it like To Kill a Mockingbird because it's a school required book, and things like that, And if we find out, like, in the month of June, like, what's our lowest, like, here's the thing, what you might have a query saying, what sale should we do this month? So you want a query that says, show me the lowest selling genre of book in June. And then we do a sale on that. So, like, maybe in June, romances are slow. So we want to do a sale on romances. We need to know what the lowest selling genre per month is. These are all reports. I mean, just let your mind go wild. What would you, if you ran a bookstore, what would you want to know? Or what, if you ran the business you had, what would you want to know? Updates. Now, update is a little bit more, not just updates. We have to insert data into these. So in those 12 tables, you need to give me insert statements. So there's data there. So when you write those queries that pull data out, actually something actually comes out, and it's not just 0 rows. So it actually works. But how is data going to be updated? What are some actions that the front end will do that will update the data? Every time a customer buys something, it will update your data. Every time a customer changes their phone number, their email address, it will update something. Every time a new customer comes online, that will update something. It'll insert, but it's also considered an update. So you'll look at these things like, what are these? How is the data going to change? And how am I going to control that? Okay. What if, like, a new book comes into stock? How are you going to put that new book in? What if your inventory changes? Let's say every time you want the inventory quantity to change, how's that going to change? It has to automatically, whenever a sale is rung up, you want that change to happen right away. Deletes. What if a customer, and this can get into a deep and scary place, but deletes, what if a book is discontinued? We don't have it anymore. What if a customer leaves? What if any number of things happen? How do we delete data, and how do we control that delete? So it's just not some random delete and everything accidentally goes, So you need to write the test cases for those, say we will want a report that shows on a monthly basis what the lowest performing book genre is. We want to know what people buy in their birthday months, or how much money they spend in their birthday months. So you write one of those test cases. Test cases are also like things we want to know. Think of it that way. Things we want to know or things we have to do. Customer needs to change their address. Customer needs to change their phone number. Customer needs to add a child to their family plan, whatever it is. You write that test case scenario, you write the code for that test case scenario so you can prove it. So here's the things that your test cases should include. So an index that maps the unit interface, CRUD test case, and SQL scripts that support the test cases. So if you say I need to write a query that's going to show purchase history, you're going to have a page on your UI that says, look for like just imagine Amazon. You know, you can go look at your orders, what you've ordered, what's coming up. So you want that, right? You know, if you're going to say I want a page that's, and you don't have to design the page. Keep in mind, you can just give me a drawing of it. See, this is what I want it to look like. This, if I were a developer, this is what it would look like, right? And then so you have to have that the test case has to be supported by a user interface page and the CRUD test. Okay, I want a mock-up of all the user interface forms. So let's not be crazy. You know, you don't have to. If your site's gonna have like 75 to 100 pages, just show me the ones that are directly related to your CRUD. Okay, don't have to show me things that don't exist. Like I'm gonna have a page that shows things that are on sale. Well, I didn't write the the test case for that. I'm not going to show you that. Okay. And then test case script SQL script, which we talked about there. So you want those. So for that part, you want a mock-up of the UI on the pages that you're presenting, that you're writing the queries for, the justification for those test cases, and why you're doing it, and then the actual code from the test cases, and that will satisfy that requirement. The last thing is create a PowerPoint presentation that explains the business purpose of your model. You can do this, or you can do a quick video. I'm either fine with either. If it's a PowerPoint presentation, I'll just flip through real quick. I find it easier for me to do things like that, to like talk about it. Make sure the videos are like maybe 10 to 15 minutes length, or PowerPoints can be however long they're going to be. But just that thing is just to describe everything you've done in step 2 here. Okay, to show me your ERD, to show me your CRUD, just sounds weird to say that. Show me your UI, things like that. Okay. Last thing, create a PowerPoint presentation. Last thing here is the rubric. I'm not going to go into this too deep because it's pretty normal. It's pretty standard. Criteria. You meet the 3rd degree of normalization, the 3rd normal form, which means no many relationships, no redundant data in the table, and no redundant data in the database. You designed all your CRUD operations and mock-up UIs, and your test cases are written out and independently runnable, so I can run them. The most important thing to take away this is you need to show me the ERD. You need to give me the code that creates the ERD. You need to give me the code that runs all of your UIs and your inserts, substate, delete statements, and you need to explain them to me. That's, if you want to boil it down to brass tacks, what's coming down to, because I need to be able to run the code, and it's got to be presented to me in a runnable way. So while I'm listening to your video or flipping to your PowerPoint presentation, I can open up MySQL, drop that file there, and go, oh, look, I created 12 tables. How cool is that? Oh, look, I just inserted all this information, and look, that query runs perfectly. Okay. That's that. So it is not a difficult project, but it is a time-consuming project. A lot of people I've talked to have come up with some really brilliant ideas, and actually, honestly, some ideas that I hope they follow through on, and one day I actually see the applications exist. So keep that in mind. And again, you can work on this all you want, and then the last minute you decide to do the final exam. I don't need to know until week 14 what you're doing. This has got to be turned in week 13. I need to know until week 13 what you're doing. Okay, so that's that. I also want to reiterate about late work. I talked about it last week. Let me talk about it this week, because this message isn't getting out, and the people who are here have heard it, but I want to mention it again, just in case you're tuning in for the first time to see what these videos are about. First, I suggest if this is your first video you've watched, please go back and watch the other 7. They will help. They will explain things. But also, if you're turning in late work, I get it. Things happen. It's not a big deal. You just have to let me know what's going on, when you plan to get it back. And most importantly, I will not grade anything turned in after week 12. Okay. If you turn before week 12 and I've graded it, I will still go back and grade it. But if you turn it in after week 12, I will not grade it anymore, because that's when I start grading final projects and everything else. And the semester's ending. So you got 4 weeks to catch up. And if you're behind, let me know. We can work out a plan. Just most important thing is keep in touch with me and keep pushing along. Don't jump ahead on lessons. I had a question today. Do the lessons build upon each other? If I don't make changes in week 5, am I going to be missing something in week 7? Not necessarily, but the information you need to write the queries in week 7 is in week 5 and 6. And if you haven't read the week 5 and 6 stuff and done the week 5 and 6 stuff, you won't be able to do the week 7 stuff. So I think that covers everything I want to talk about. I'm sorry about not going through the examples of in, any, all, and exists. But again, I've covered a few of them in the past. They're not super difficult. And keep your eye on the announcements to see if time's going to change for Wednesday. I'm not sure if they will, but they might. But I'll let you know. All right. I got nothing else. So you guys have a good week. Keep going strong and keep in touch with me. Talk to you later. Bye.